Algebra 1, Section 3.8, finding and estimating square roots. A little bit of language and definition for you. The number a is a square root of b if a squared is equal to b. Now, just to be clear, we're saying the number a is the article a, right? That's just part of speech. Is a square root of b if a, that's the same a squared equals b. Now, you should recall that there are two solutions to something like this, okay? So for example, what is the square root of 16 based on this definition? Well, that would be negative 4 and 4. Not just 4, but negative 4 and 4, okay? Now here's the part that most people miss. Listen closely to this. When we use the square root operation, we're only dealing with the positive square root of n. Only the positive. So in one sense, because of the way this is defined, the square root of 16, that's two numbers, negative 4 and 4. But as soon as we go ahead and use this operation, we're only talking about the positive square root of n. Here's the difference. If I have x squared equals 9, there are two solutions to this. X equals negative 3 and 3. But if I say square root of 9 like this with that symbol, that's just 3. Use the positive number only. Okay? Now, moving on. If you have a negative in front of a square root, that's going to be a negative number. You know, negative, the square root of 36 is negative 6. However, if you have the square root of a negative number, that's not going to be something we're going to deal with in Algebra 1. That's going to be a non-real number. So the square root of negative 4, that's nothing to us right now. That's actually either called imaginary number or just sometimes I call them non-real. And we will deal with those in, in Algebra 2. Okay, so looking at some examples, simplify each expression. Again, if you're just square rooting, as this is, square root of 25 is just 5, just the positive number of that. Now, when they give us the symbol, of course, that does mean two numbers. And did you know that when you square root a fraction like this, you're really just square rooting the numerator and square rooting the denominator? So this would be plus or minus 3/5, because the square root of 9 is 3, the square root of 25 is 5. You say, why is that? Well, because 3/5 squared was like saying 3/5 times itself is 3 times 3 is 9, and 5 times 5 is 25. And again, just keep the plus or minus as they have. Here you have negative the square root of 64. That would be negative 8, because the square root of 64 is 8. Here you have the square root of a negative number. I just told you that that is going to be undefined or non-real, you could say. In fact, I'm not even sure what the book says about this. Let me look. Yeah, undefined. It's actually a non-real number. There is an application for this. If you've ever noticed the I button on your calculator, that's what this is. This would be actually 7i, but we'll deal with that in your Algebra 2 class. All right, and then finally this fraction. What number times itself would give you 1/16? Again, it's going to be plus or minus. And then what fraction times itself gives you 1/16? That's actually 1/4. And I tried to explain that one just a little differently than I did this one, but I could explain it just the same. The square root of 1 is 1, the square root of 16 is 4, and it's plus or minus. Okay? This one says, tell whether each expression is rational or irrational. Recall back to section 1.3, I believe it was 1.3, where we diagrammed the number sets. All real numbers, okay, so not non-reals. I already ruled those out for your whole algebra curriculum. But of the real numbers, you can divide them into two categories, rational and irrational. And the rational numbers, let me give you just a quick explanation of that again. An irrational number is one that cannot be written as a fraction, top over bottom kind of fraction. And in decimal form, it is one that has no terminating, that never terminates and never repeats. Now, there's a little bit of a trick to that, because when you pick some wild kind of fraction, 43 divided by 197, the limitations on your calculator, you're probably not going to be able to recognize the pattern in the 9 digits, but I'm telling you there would be a pattern, okay? It might be 30 digits long, but there would be a repeat to that. It would be a repetent, okay? If it can be written as a fraction top over bottom, it is not a non-terminating, non-repeating decimal, okay? But the irrational numbers cannot be written as a fraction. Therefore, they do not have that terminating. They do not terminate, they do not repeat, Okay. The flip side of that is rational. If it does terminate or repeat, then it is a rational number, and those can always be written as a fraction. Okay. We have a feature on our graphing calculator that'll turn a decimal into a fraction, and if you take the square root of 3 and then you run that key sequence, it won't give you a fraction because it can't, because that doesn't exist, because it's an irrational number. Okay. So with that, we can answer these questions. Plus or minus 12, that would obviously be rational. I wonder if they'll just roll in here. Oh, that's better. That's better. I like that. Okay. What about the square root of 1/5? The square root of 1/5 would be irrational. As we look at the decimal, see, 1/5 is not a crazy number. Not like the fraction I just gave you. So we can kind of look at the decimal and see if there's any repeating going on. But basically, really, there isn't a fraction that would multiply by itself to give you 1/5. To give you the square root of 1/5. Okay, so this is an irrational number. Here we got negative 2.5. That's obviously rational because it terminates. Here you have 0.3 repetend. That's obviously rational because it repeats. Now you say, well, why is that one different from part B? Well, because 1/9, the square root of 1/9 is 1/3, right? 1/3 is 0.3. See, 1/3 times 1/3 would give you 1/9. Okay, so the square root of 1/9 is 1/3, right? Square root of 1/9 would be like pulling these apart. And I don't know if I'm pulling them apart is the right way to say it, but I hope you understand what I'm saying. It's late in the day, I'm telling you. Anyway, it's rational because the decimal is a repetend, but the square root of 7 is not. See any pattern? And again, there is no fraction equivalent to this. Irrational. Okay. Sometimes I'll write a list on the board. I don't know if I've done it for your class yet. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144 is probably as far as we need to go. These are the perfect squares, right? This is 2 squared, this is 3 squared, 4 squared, 5 squared, 6 squared. These are the perfect squares. Keep an eye on those as you navigate your way through the number system, through the lesson, and in particular, a problem like this. Between what two consecutive integers is 28.34? Now, don't reach for your calculator yet. Excuse me, the square root of 28.34. Don't reach for your calculator. See if you can think this through and find the two consecutive integers. We know what that is now from a previous lesson. That this number would be between. Okay, pause the video if you need to, because I'm about to give you the answer. You see, yes, you could take your calculator and find the square root of 28.34, and it would be, a certain decimal. I don't have my calculator close to me at the moment. Well, I guess I can reach it. I think I'm going to need it on the next problem, so I'm reaching to get it now. But I haven't done this problem this year. And yes, you could get the answer that way because it's going to be a particular decimal that you can identify between, whatever, 2 and 3, 3 and 4, 4 and 5, 5 and 6, whatever. Okay, but instead, what I'd like you to see is the fact that it's between the square root of 25 and the square root of 36. See, because 28.34 is between 25 and 36. Well, that means that it's between 5 and 6. No calculator needed. Now, I say that because the calculator is probably needed on this one. I'd be really impressed if you could do this without a calculator. I'm using my calculator. It says round to the nearest hundredth, so that would be 2 decimal places. It's 5.32. Was that the same number as the previous problem? I believe it was. Yeah, so now we're just kind of testing that out. And yeah, it's between 5 and 6, right? It's 5.32. Make sure you round correctly on this problem. One more. Suppose a rectangular field has a length 3 times its width, x. The formula d equals the square root of x squared plus, in parentheses, 3x squared gives the distance of the diagonal of a rectangle. They must have gotten that using the Pythagorean theorem. Oh, you don't know what that is yet. That's the next lesson. I'm sure you do know what the Pythagorean theorem is, but that is actually the next lesson in our book. It says find the distance of the diagonal across the field if x equals 8. So this is just a plug it in kind of problem. Square root of 8 squared plus 3 times 8 squared. Make sure you follow your orders of operation here. This would be the square root of 64 plus 3 times 8 is 24, and 24 squared is 576. So that's really the square root of 640. You could use your calculator on some of this. I wouldn't be mad at you for that. But I just wanted to show the work there. And it comes out to about 25.3. Did they say what to round to? They did not. Let's see what they do round to. Yeah, about 25.3. Yep. Okay, thanks for watching.